Hey guys, what's up? Eddie Alho here with KissAnalog.com. So today we are going to do our third in the series of power supply design. We did a power cord on the first one, we did a fuse and a thermistor and a switch I think on the second one. And the third one we're showing the schematic and we're doing the transformer. Big old 250 V8 boy, big old toroid. So we're going to hook this up. I'm going to show you the schematic. We're starting to get too many parts, so I'm going to show you the schematic of that and how to hook this up. And we're going to look at some measurements here on the bench real quick, and then some measurements on the scope. And I'm going to show you why we use that thermistor once more, and why there's an inrush in your transformer, and how that thermistor protects it. So we're going to do that. We're also going to talk about transformer regulation and what else. We're trying to do this one kind of quick and bite-sized, so I think that's a bite. All right, hey, thanks guys. We'll jump into this test right now. Bring the camera over here. Okay guys, so this is the schematic of the circuit so far. We got our plug. I'm going to call it P1. Then the switch, sorry I drew this line before I put the switch in, so that should be open right there. Sorry about that. So got the switch and SW1, F1 for a fuse, and RT1 for the thermistor. And then I'm wiring up the transformer, and let's talk about that. Oh, by the way, my plug here goes to chassis ground, you know, so that's not connected right now on my plug. See how I've done my plug? I've only got 2 wires, so kind of skip that part for now because don't really have a chassis to tie it to. Not really worried about it. So 2 wires right now. Old school. Alright guys, so as you can see on this transformer, I hope you can see this. The symbol right here on the transformer shows 2 windings on the primary side over here. Primary is what connects to main power, and secondary side is the isolated side, the other side of the transformer. Okay, so on this side we have blue, gray. That's the first winding, and there's a little dot on that guy that might, hopefully you can see. There's a little dot here. That's violet and brown, and the dot appears on black, red, and orange and yellow. Dots on orange, black, blue, and violet. And I just realized something as I'm looking at this. I forgot to show the lines in here, which is the iron core. Okay, so we got blue, gray, violet, brown, black, red, orange, yellow. And I got the dots in here. I make my dots a little bit bigger. Okay, and the dots are the polarity. So when this one's positive, that's positive, that's positive, that's positive. So it just shows that when the sine wave is in the positive portion, that they're all in the same phase. When it's going negative, those dots are all going negative together. Just shows that that's the polarity of all those windings related to each other. Okay, so there's the connections. Here's all these wires. So now I'm going to connect them to the end of my connection, you know, these little terminals here. Okay, so now I connect them to these little guys, my power cord. Alright, and I just have to push them in there and then push these little so I just push them in the hole, and I push these little levers down, and this little block shorts all 3 connectors together, all 3 wires together. So pretty cool little block. And this one was just a tube blocker, a 2-pinner, and it's just slightly, it's a Waggle, it's just Waggle brand, and just slightly different. Really cool connections. Got them on Amazon. I'll see if I can put a link down below, okay? They're really neat. They're fairly inexpensive and a great way to build things, I think. And they hold super, super strong. I think you'd break the wire before you pull them out of there. Or broke the connector, maybe. I don't know. They're pretty strong. Alright, so that's the connection. So I'm putting both windings in parallel so that both the dot ends go together and both the negative ends go together. And this side I'm leaving open for now. We're just connecting up to a transformer. We're going to power it up and see what it looks like. Okay, I'll just demonstrate one of these connections, just show you how easy they go. I'm going to take the blue and violet and put them in here. So there's my violet. I just push it. See, I've got it stripped that much. I just put it in there till it stops. And then push that little orange lever down. See? Locks right in there. Okay, now I need my blue one. And reach up, pop, whoops. Pulled the wire out with the lever. Okay, hold it in there and then push with it. There we go. Now I got them all locked in there. Nice solid connection. Really cool. Okay. So then I gotta take my brown and gray. I'll just go ahead and do that right now, real quick. I guess it's pretty fast to do. Wanna try to pull them out so they're not crossing each other. Brown. It's in there. Snug, snug, snug. Okay, and then the gray one. There we go. Alright, connected. There we go. Now I just don't want these guys to short together, so maybe I'll just put some tape on the end of them, keep them from shorting. Alright, I'll be right back. Okay, I think I'm going to do it this way. Just going to lay those wires in there so they're spread apart, and then bend this over, hold them in place. There we go. I just keep them from moving around. Okay, now I'm going to take my hand tech current meter and just degauss it. Push this button in a few times, hold it down, and then I will put it over the wire with the fuse on it. I could put it over these two. And by the way, it's a little trick. If I wanted to read, if this meter wasn't able to read all the current, I could go over one wire since they're in parallel, and then I could just verify that they have the same current and go that way. So I could read one at a time and know that, you know, most likely I could just double that number. But anyway, I'll just go over here. I guess I could go over here and grab both of them too. So maybe I'll just do that. Alright. Okay, so we're ready to read current. Okay, I decided to pull the black and red one out. I was going to read the current on the primary side, but I think I'll just read the current on the secondary side. So just pulled those out, and you can see black is the positive. Well, relative to the input, doesn't really matter. But I'll just go black and red. That doesn't really matter, I guess. Alright, so we're ready to do a test. Okay guys, so here is the test setup. This lead right here is going to this meter right here. It's this coax with this these little clips, and the coax to the banana over here. So that's set to AC volts, and maybe I'll prop it up with something like a screwdriver to keep it from rolling over. Okay, and so here's the plug. Okay, so schematic, there's my plug, and it's got red and black wire. Okay, the red wire comes up through the thermistor and then to the transformer. So actually I have the thermistor right here. Now this path to the transformer and back is series, so it doesn't matter what order really that these go in. So I've got the thermistor down here just because I didn't want to put all these parts on one thing. So thermistor's right here. Okay, it's a 10 ohm thermistor. Okay, so on the other lead I have On the black one I have the switch, okay, coming off the power cord, and then it goes to the fuse, and instead of the thermistor it just goes through the current meter right to the transformer. So if I was going to draw it on meter, I'd have my little current meter coming right here. That's where it's reading. And then my voltage probe, my voltage, I've got one here and one over here on the blue and gray wire. Okay, that's where these guys, sorry, oh, I'm sorry, I forgot, I changed my mind. I'm going to put them over here. I got the voltmeter on the black and red wire, okay? I'll erase this one. That's a confusion factor, right? That's why I put it in pencil, because I might move these things around. It's a good thing I did, I guess. Anyway, okay, so volts are over here. That's this voltmeter right here. This guy is looped right there. So I'm going to turn on power and we'll see the current rush into the transformer, and then we'll see the steady state current afterwards, and we'll see the voltage here on the transformer. Okay, so alrighty, I'm going to turn it on one time so you can just watch this meter turn on, and I'm going to turn on the power. I'm going to plug this in, and then I'm just going to hit the switch, and then we'll go up and look at the oscilloscope, see what it looks like. Alright, hey, before I do that, I'm going to determine if this is on position or if that's on position, okay? So I'm just going to show you how to check that. And I got this on ohms. I'm just going to put on a beeper, actually. Let's just, yep, there we go, beep. Okay, so let's see if we get a beep. No beep. Okay, so that's off. So towards the connection is off, away from the connection. Let's verify that. It's always good to double verify. Yep, that's on. So they're connected now, and that'll be off. Triple verify, right? Okay, there we go. So that's on, off. Okay. All right, just wanted to show you that. That's a good thing to check before you power up. Hey, by the way, I think this meter is being given away on another video, so I think we might have a winner on that one. I gotta see when I'm supposed to end that, but yeah, nice meter, huh? Alright, let me throw the switch, hope for the best, right? These guys are not touching, so I've checked that, everything looks good, so we should be good. Let's give it a go. Should see voltage jump up here. This meter right here is not reading anything, it's kind of floating around. Alright, so we got 28 volts on the output. 28.35, and it says 60 hertz. That's what we'd expect. It says 25 volts on the thing. Now, it's 28 volts, not 25. Why is that? Now remember also, this is RMS voltage. It's supposed to be 25 volts. I'll turn it off. Okay, it's just millivolts. It's just kind of floating around. If I disconnect this lead, you'll see the same thing. Watch this, just to verify that. See? It's just kind of floating around. But okay, now if I flip this back over, we got 60 hertz and 28.2 volts. That's because it's not loaded. That's called transformer regulation. When this thing's loaded, it should drop down to 25 volts or thereabouts. Okay, it's usually around 10% regulation, I think, on a transformer like this. This is a toroidal transformer. It's a donut. It's a toroid. These are awesome because the magnetic field is kept within the core. You've seen the magnets, right? Where you have a bar magnet the flux lines go out and try to come out. They come out of one end and try to go in the other end. And so when they come out of a bar magnet like this, they come out and come in. So this big old flux field can radiate and cause issues. This is kind of a bar magnet that's kind of folded over and touching the ends together, essentially. But it's a solid piece. So instead of those flux lines having to come out of the bar magnet and come around, they're already connected. So it keeps the field really tight. So they're great for audio and things where, things where you don't want magnetic flux lines coupling to other things. So yeah, Toroid's really great. And I got this on Parts Express. You can also get them on Amazon. And by the way, just to give you an idea of the size, this is 250 VA. They rate them in VA, volt amps, not watts. You might say, hey, volts times amps is watts. So why don't they just say 250 watts? Because that's part of what I want to show you in the next video when we hook it up to the load. Okay, we're going to get into all that power quality stuff, all right? Okay guys, so what we're going to do is we're going to turn the switch on and we're going to see what kind of inrush current we get to the transformer. Now you're saying inrush current, why? We don't have anything hooked up to the output and there's no capacitors, there's nothing, there's just a transformer going nowhere. But that transformer has to build up a magnetic field, and so it's a bunch of wires wrapped around a magnetic structure, and that is going to rush in and build up a field, and we're going to see that. Okay, so setting it up, we've got voltage probe on the channel 1, current probe on channel 2. So what we're going to do is go to setup and set the source for the trigger on channel 2, which it is. We're going to do edge type. We're going to do edge as it crosses. Now a little talk about that. Now it could turn on when it's an AC waveform, right? So we're going to, first of all, we're going to center it in the middle of the screen like we do. I'm going to just push this button in, centers it. I'm going to push the voltage in to center that. See, it centers them at 0. See that? So they're both centered. Edge type, but it could be that when I hit the switch it might grab, you never know what part of the waveform. We're gonna put the trigger on the positive part. See that little line there? So we're gonna trigger right about there. It says about 2.4 amps. It's like, wow, 2.4 amps, really? Well, let's see. I've got this set at 10 volts per division and 5 amps per division. I should probably go, yeah, 10 volts per division is okay. So let's do that. This right here shows the edge trigger, channel 2, DC coupled. So this shows all the information down here, how we have it set up. Alright, so we got that. And we got the voltage, 10 volts per division, because we're expecting 25 volts RMS, meaning, the peak voltage is going to be higher than that, right? So, alright. And then 10 milliseconds per division. Well, 60 cycles is about 16.7 milliseconds, so one cycle will be a little bit more than a division, so that sounds about right. So I think we're looking pretty good. See, yeah, 10 milliseconds per division. That's the horizontal, and we got the vertical set up, and everything's referenced in center. And okay, the measurements, we got max for current, so that's good. I guess we're going to look for positive spikes, so we might have to try it a few times. Maybe we won't get the positive. And I got RMS for volts, but I could go max for volts. I got duty cycle, we don't care about that. Here, let's go to measure. And channel 1 is the voltage, so channel 1, type. There's peak to peak. I guess we could do that too. Let's do peak to peak as well. Then we have RMS. Let's do max as well. Okay, so we got max. It kind of shows you what max is. This shows you what peak to peak is. I love this about this Signet, how it shows you help on the fly. Amplitude is kind of like that. It's kind of like a peak to peak, but a little bit different. I don't know if you can see that, but okay. So we have max. We have max, peak to peak. Oh, duty. We don't need that. Let's turn that off. Now I see how I'm scrolling all the way through this this multifunction knob. I can also use these. It shows, whoops, shows the arrows there. I hit something there. Sorry about that. Here, I turned off the measurement function. That's okay. Let's go type, and I use the down arrow here. I go up and turn that duty cycle off. And then I go back up, and let's go to RMS. One more. Oh, shoot. Timed out on me, I think. Oh, wait, what the heck? Why is it doing that? I don't know why it's... that's interesting. That is interesting that it's doing that. I don't know why. Because this is supposed to move it back and forth. Haven't seen that happen before. I guess I'll do it with this. Move it over. Now I wonder if I can. That's weird. I wonder what mode I'm in that's making it do that. I don't know. So I'll just do it this way. RMS. Okay, we got them all selected. I don't want to try to figure that out right now. So turn that off. Okay, so we're going to measure peak to peak, max, RMS, and on channel 2 we're doing max. Alright, now I go to single trigger. It'll trigger one time and freeze. Right here it says ready to trigger. Okay, and it's going to trigger right here in the middle of the screen. Okay, let me go flip the switch. Alright, cool, that was awesome. That was lucky. First one. Now here, one thing I can point out is you can see what the waveform looks like, right? I'll spread it out a little bit. You can see the waveform. This is the voltage, right? Yellow. But it turned on when I was right about here. See how we only got part of that waveform? We got this part right here. You know, right in here. So I turned on and it just snapped up to here and then followed the waveform. But when I did some inrush current videos, I was talking about switches bouncing, inrush current, so on. So that's what I'm talking about right there. See that bounce? Let me zoom in on that, just show you what I'm talking about. Because there's a good example of a switch bounce. Look at that. Heck, I was doing a banana jack. I did better than that. But look how many times. 1, 2, 3, 4. It bounced 4 or 5 times. Okay, that's switch bounce. That's cool. I mean, it's cool that I got to show that example. Okay, so another thing I want to show you is you see how it goes negative, the waveform. Look how this one looks compared to that. Look at that. That doesn't look very sinusoidal. And look at this dead time right here. What's up with that? See the waveform? We turned on here. How come the waveform's not looking normal? Well, there's a huge pulse of current right there. And what that did is it pulled the voltage down. So I did another video on this, a complete video on this, but I'll just tell you real quick. See, it's 5 amps per division, 510, about 12 amp. Oh, this tells me right here 12.8 amps. So 12.8 amp spike. So when that goes through that primary winding, there's resistance in that primary winding, and you're going to get a voltage drop because of that. But also, I think what happens is we actually saturate the core, so the magnetic field collapses. I think that's happening as well. So interesting, right? So that's what happens even with the thermistor. Hey, we're only 12.8 amps. Just think what it would do without that thermistor. Oh, you say you want to see? Okay, let's try it. Let's go to single. I am going to jumper out that thermistor. I'll be right back. Okay, I just jumpered out the thermistor. See, there's the thermistor. All right, so I jumpered this bad boy out of there. It's a little 10 millimeter SL22. All right, jumper that out. So now we're gonna see what the inrush current looks like. But I can tell you right now, I'm at 5 amps from the last one. I'm gonna go to 10 amps. And you know what? I might even go to 20 amps. You're thinking I'm crazy probably, but here, let me throw that switch. Wow, we got a trigger on the negative edge. Look at that. It probably looks similar to the last picture, but we're at 20 amps per division. Now this is capturing max, so it's capturing the maximum positive one. It didn't capture this for us because that's more of a minimum, I guess. So we have to go 20, 40, 60. That's like 70 amps plus. So thermistor gave us 12 amps. Without it, we get 70 amps. Well, you know, a little more than 70 it looks like to me. So there you go. That's why we have a thermistor. And now I don't have to choose a fuse for 70 amp pulse. And I can choose a fuse a little bit more, you know, acceptable to protect my circuitry. Alright guys, hope you liked that video. Give me a thumbs up if you like this video series. I appreciate those, and we'll catch you next time.